Good morning, everyone, or good afternoon. I hope you can hear me. Welcome to the webinar. I'm happy to see you all back online again. We're going to have a very interesting presentation today by Derek Davy. I'll introduce him in a minute. I'm going to forego the territorial acknowledgement because I'm joining you today from the Netherlands. So I'll just jump straight to the housekeeping rules that the speaker will talk for about 30 minutes. And then if you have any questions for the speaker, please write them down in the Q&A box, not in the chat, but in the Q&A box. And then we'll get to the questions after the presentation. So let me introduce the speaker of today to you. So I already mentioned his name, Derek Davy. He's the CEO and business lead of Econse Water Technologies. Econse stands for Ecological Conservation. And Derek works directly with customers, including craft brewers, greenhouses, and vegetable processors to help solve water pollution issues. And that's what he's going to talk about today. He has over 15 years of experience with international business development and technical sales for global manufacturing. During his experience in several water-intensive industries, Derek became an advocate of clean tech solutions and sustainability, and this inspired him to help found Econse dedicated to eliminating water pollution to help mitigate the effects of climate change. And their solutions help businesses and communities across Canada to meet their environmental obligations while growing their businesses and helping local economies. So it's my great pleasure to invite Derek to the floor and start his presentation.
Hey, awesome. Good afternoon, everyone. Thanks, Roy. That's that's a humbling introduction. I really appreciate that. So let me just get my screen going here, everybody. Just bear with me one sec. Let's go with. Did I lose the Zoom people? Can you guys see that?
Not yet.
No.
Okay. How about now?
Perfect.
Yes.
All right. And you can see the full screen and everything. Okay, wonderful. All right, sorry for the technical stuff. So normally I'm giving these presentations to customers. So this is a rare treat for me to be able to talk to you all. And I promise I won't turn it into a sales pitch or anything like that. But as Roy mentioned, if you do have any questions, please pop them down below. And we'd love to dive into it as towards the end of this thing, because I think there's a lot to unpack here. I mean, Lord knows I could talk about each one of these subjects for a couple hours on their own, but we're going to try and stuff it all in here. And I did want to give a quick shout out to our friends, our team over at the Institute of Nanotechnology as well. We love working with those guys. We're really proud of the work that they've done with us on our OzoCab technology over there. Okay, so water is something that intersects almost everything we do as a society, yet hardly anybody understands it. And certainly even less so when it comes to the water pollution crisis that's impacting the whole world that we're in right now. This sort of crazy era where we're trying to figure out, how do you move forward and deal with all the stuff that's legacy and dragging behind us. And it's another strange thing that we hear a lot about all these other issues concerning climate and environment, but it's, water is suspiciously absent from that conversation. Those of us that work in water, we understand that, but it's far from me to say that it's a conspiracy or anything like that. But there's definitely, when I think about it, two things that hinder our willingness to discuss how we can even attempt to reduce something like water pollution. First, it's expensive, or at least perceived to be. Second, it's complicated, or at least perceived to be. And you don't even need a third. That's the third strike. You're out. Those first two will end that conversation pretty quickly. So how do we navigate this one, and how do we explain and raise awareness and promote solutions, which I'm a little passionate. I kind of believe that's our responsibility and our duty to do. This is a heavy topic, but we're going to do our best to get into it, keep it light and positive. And I know we're dealing with the university here, so I've only included one formula for everyone, and it's one that I think you can understand or get behind, regardless of what level you are in, what level you are on in this conversation. And this formula is as thus: put less crap in the water, and that's good for everybody. But easy to say. So how do we, all jokes aside, how do we do that in a world where urban agriculture are kind of pushing up against each other? We got all these growing pains from aging infrastructure. We got rapid demographic shifts that are causing, a nightmare for planning cities. We've got, thanks to everybody working at the university, new detection levels on discovering emerging chemicals of concern that keep us up all night. So we're going to try and unpack this and try and find some kind of concept or simplified way that we can approach this topic to actually get some traction, get some measurable results. So let's start right here at the beginning. Something a little over a decade ago, I started this company with my other partners. We were all from different water intensive, different backgrounds in different water intensive industries, from quality control in food and beverage manufacturing, all the way through to myself working in textiles. I was kind of on the complete other side of the things, part of the problem, not so much part of the solution. And it was actually working through some of the issues around offshoring of manufacturing, relocating of production, that I suddenly came face to face with this issue of water pollution when we had to put in a treatment at one of the facilities that I was, representing as a sales guy. And that was extremely complicated, extremely expensive, and kind of a light bulb went on, oh, that's why the river turns yellow and blue and purple every time we change a dye SKU, and I felt terrible personally about it. And it takes time, but after that, I was really fortunate to be able to sort of get off of that hamster wheel and find some other people who were passionate about the environment and passionate about new and innovative solutions. And they started talking to me about this idea of on-site treatment. Being a normie, I kind of imagined the way we would fix water pollution is just put some sort of big straw into the ocean and just suck out the pollution. Of course, if you could do that, well, we would have tried it already, but it doesn't quite work like that. And short of laser beams and other things, to fix the water problems, we really looked at what could be done. And when I heard about this idea of, stopping the water pollution where it happens, the light bulb went off in my head, and I kind of convinced them to, if they could build it, I can sell it, and we started working together. Now that was quite the ask, and the first couple of years were definitely rocky on the entrepreneurial scale of things. And that's part and parcel for this industry, and part and parcel for that area where research and innovation and everything in startups and stuff kind of overlap. But we stuck with it, and over the years, we've had a whole bunch of wonderful success stories that have come from this. Last year, we were able to win an award from Water Canada for one of the most innovative wastewater systems. We've been able to work with all different types of industries from coast to coast to coast, and kind of put together something that we think is really valuable to the economy, which is helping businesses be able to have the tools to be able to fix their water in an affordable or easy to adopt way. And it's kind of fantastic. We've had a real great opportunity to be able to work with a cross-section of the Canadian and North American economy, and develop sort of what I would call niche solutions for community development and industrial or pre-treatment water. And then, of course, the emerging ag and greenhouse space. Each one of these has really specific water chemistry issues or technical challenges, around footprint and scalability and all these other types of things. But, that gave us a really great experience to really be able to see what are kind of the problems that are going on out there. And after a decade of working on this range of issues, I can now declare that we have found the solution to pollution. And it is not dilution. It's decentralized treatment, or, and put it another way, fixing water one drop at a time, one city at a time, one region at a time, one business at a time, basically stopping the pollution on site before it moves to the next place or before it becomes exponentially more difficult to treat or manage, or all these other kind of things, which seems completely obvious, except unfortunately it's not. It's actually a little bit tricky. We are in a tough time for those of us who have ideas to make things, how to make things better. How to do things. It's noisy out there. It's complicated out there. But fear not, we'll get there. Like I said, one drop at a time. So I'm going to now kind of break this down and give an overview of kind of how we think about this, how we look at this sort of problem, and where our company fits in a little bit in terms of putting solutions into the mix. I kind of think of it as zones or concentric circles of potency, which sort of highlights, how and where decentralized solutions can be applied to make an increasingly larger impact or reduce loading, whether it's going to a treatment plant or going to nature. Again, sounds obvious, but it's not. Okay, so this is, that sort of big zone of the cities, towns, and industries and things like that, kind of surrounded by agriculture and greenhouse activities, and then sort of surrounded by stormwater runoff, and then eventually, it's God's problem once it gets out into the lakes, rivers, and oceans. So kind of thinking of it like that in terms of how we've got these different zones that we try and adapt our technology to, or our niches to, for problem solving. Of course, each one of those areas has their own, like I said, 2-hour deep dive on what the heck's going on and how the heck do we fix it. But let me just give you a quick kind of overview of some of this stuff. So big cities, big problems. Tough for a little guy like me to really even join that conversation, but where we do get involved is with what I would call water intensive industries. So these are businesses that use a lot of water for their manufacturing or for their production, like craft breweries. But they're not the only one. There's a whole bunch of different types of industries that use water for their production that have a water to product ratio that means that at the end of the day there's quite a bit of garbage left over. And right now it all goes through that magic hole in the floor and disappears out of sight, out of mind. But decades of operating like that have caused a whole bunch of problems. And I'm mentioning this first because this is kind of where I think, the rubber meets the road. This is one of the first areas to start making an impact, whether they're in a big town or a small town. And that is, on-site pretreatment, reducing the load going into that treatment plant, recycling the water where possible, or reducing the amount of water leaving. But, even when they reduce the water coming in on the front end, you're concentrating the stuff coming out the back end. And certainly that's going to be a challenge. A couple of weeks ago, we had a great conversation with the city of Guelph and and Stephen and their sustainability panel over there, and we got the chance to talk about some of these issues on how pre-treatment of the industrial wastewater can actually help reduce the cost and operation for the treatment plant. And certainly that's needed right now. Those big upgrades for those big plants, those are years in the making and millions of dollars. So we're having a crisis right now that can't wait. So this is number one place where I think we can make some impact. I mentioned small and mid-sized communities because that seems to be where we're doing a lot of work, where we're doing a lot of activity, and we're doing a lot of help. And I think that's just because demographic shift post-COVID out into a lot of these places. We've got remote work, we've got work from home, we've got housing pricing, quality of life, a whole host of issues, but rapid demographic shift into communities that had very stagnant growth and suddenly a hockey stick. So those are the places that are having a lot of challenges, but it's also, in my opinion, a great place to implement new ideas, new technologies, and new solutions and kind of get it right. Because a pivot in a small scale or mid-scale community or business is a lot easier than if you ask McDonald's to implement a new SOP. I mean, that's turning around a big ship, when you're at a big company or implementing a change in a town like Toronto or something like that. That's a lot to move the needle. But in a small or mid-sized community, I think we can do it very effectively. Just to touch a little bit on our ideas for helping small communities. There's a great report that went out from Frontenac out near Kingston and talked about decentralized systems. Decentralized systems for helping infrastructure issues. So these are either subdivisions that aren't able to connect into a parcel of land or a subdivision that needs to be opened up, and the cost of moving water from there to a major treatment plant is significant, or it's a rapid growth within the infrastructure, and they can't manage it, and so it needs supplemental treatment either at the treatment plant or somewhere in that system to be able to reduce those loadings. These types of ideas, although like right level compared to some of the complexities of the work that I'm sure you guys are researching on, it's still a super important baby step for helping these towns get a grip on the cost of treating it. Because if they don't grip it, rip it, it's out in the lake and we're all swimming in algae. That's basically how it works. Okay, on to the next lovely story here. So all around feeding us are agriculture and greenhouses. Want to talk about two things that's going on there. In the agriculture space, some of you may have heard of Holland Marsh region. That's where a lot of the carrots are grown for Ontario, and quite a bit of Canada, whether they're your carrot muffins or Campbell's soup or bag of jumbos. There's a lot of stuff going on there. And of course, being right near Lake Simcoe, there's a huge risk of all that runoff getting out into the lake and combined with urban sprawl, creating a really bad scenario. We work with the farmers there with what's called closed loop systems or water recycling systems, so that not a drop of water gets into Lake Simcoe. Again, not rocket science, but super important piece of technology that allows those businesses to grow without growing their impact on the environment. So that's jobs, that's economic growth for the community. That's all kinds of things that help become a positive catalyst, where you can actually turn little action over here into a booming and sustainable agriculture and urban community, which that's a win. We love that stuff. Greenhouses, super important. Anybody that goes shopping at Whole Food buying organic strawberries knows that we are going to need a lot more greenhouses if those prices are ever going to come down. But they're a really important part of the Canadian economy in order to build resilience and supplement our food supply. But there's like a fire hose of fertilizer coming out the back of a greenhouse. Even within that facility that recycles and reuses a lot of that water, there's still that concentrated nutrients have to go somewhere. And unfortunately, it's kind of hitting the land application and making its way into all of the waterways. And it's a little bit of a challenge. So we're working with greenhouses to help, reduce something like 90% of the phosphorus coming out of there. Again, not perfect, but it's a great place to start compared to, the practices that were in place before. We work also with the cannabis industries, which have the same issue, if not worse, because they don't recycle the water as much because of the high dollar value per crop. But again, the problems are solved in the same way. Stop that pollution on site, remove it, dewater it, whatever it is, so that you've got your cleaner effluent leaving that facility, so that it can meet whatever regulatory targets are there for discharge. And I'm just going to put another note on greenhouses here, because in November I am going to be speaking with the University of Windsor. Now, I hope they're your friends, not your frenemies down there, but we're going to be talking with the University of Windsor about the future of greenhouses. And one of the things I'm going to be talking about is a question that I have, is why are all the greenhouses on agricultural land? There's a whole bunch. Now, I get it. A couple years ago, maybe several years ago, those were the cheap seats. But but today there's so many underutilized real estate properties in whether it's a developer's portfolio, a bunch of old Kmart's and Zellers and byways and whatnot that need to be refurbished. I think there's a great opportunity to combine, the high-tech sector like greenhouses with technologies such as water recycling and water treatment, to be able to allow a business like that to operate in a small town without having a huge impact on their infrastructure, and simultaneously bring great jobs and a great building a real community of innovation and opportunity. So not sure if anybody's working in that space, but I'm just throwing that one out there as a cool and groovy idea. Stormwater. Well, sometimes it's too big to handle, especially if you live in North Carolina or Florida, as our shout out to Darren, who's down there. Stormwater and runoff is another kind of last line of defense for stopping excessive nutrients and whatnot from getting out into the environment. Several years ago, we were really fortunate to be involved in a project with the Everglades Foundation and the Ministry of Environment of Ontario for the George Barley Water Prize, which was basically set up to try and extract excessive phosphorus from impaired bodies of water. And again, we worked up in the Holland Marsh Canal region, where they had all this network of canals before it was going to be pumped back into the river. That was set up as a tricky technical challenge because it was high TSS, cold temperatures. That kind of eliminates biological as one of the tools for removing excessive phosphorus. We had, there's some funny videos of me standing around a parka talking like a fool out in the middle of nowhere several years ago, so definitely look those up. We had a great opportunity there, and something that really opened my eyes in terms of understanding this issue, and that is collect the non-point back into a point so that there can be an opportunity to treat and reduce that phosphorus before it goes back into that bigger body of water or connects into that tributary. And I think this is something that's really important. I'm having a difficult time convincing everybody in Ontario about this, but we are building a great project with in Ohio with the Maumee River Restoration Project, where again, the main opportunity for sedimentation and stormwater is, somewhere between wetlands and natural attenuation. Well, those are great, but they're in short supply and we're not getting more of them. And additionally, they only work half of the year because they're biological based, and the other half of the year, they don't really have a shot of that. And when it gets high TSS or cold temperatures, they're overwhelmed. So we're proposing putting active treatment in to supplement wetlands, and potentially add, be a phenomenal opportunity, future site for additional monitoring and investigation into other, chemicals of concern. And because God knows it's going to be phosphorus today, but then it's many, many other things. Okay, so that's kind of our vision for how that can have an impact there. And again, trying to stop things before they get past the gate. And then you get out into the lakes, rivers, and oceans. And, whether it's the excessive nutrients or the combined sewer overflow, we're really just as a society throwing our hands up and saying, well, now let time deal with this. That is the strategy, but that's not working out so great. It could work out great if we were putting less in. But because we're putting so much, because our inputs are going in so high, we don't even give nature a shot to be able to do what it does, which is heal. But, what if we could reduce the loading going into whether it's treatment plants or downstream into the environment? What if we could make it, not great, but better, incrementally stepping forward? Would natural attenuation, would wetlands, would the environment be able to pick up that slack? I mean, I kind of think, yeah, I kind of think like it would. And I definitely know that this is something that we can make, measurable improvements on in terms of knowing how much is being discharged. And so that's my thoughts on that. Okay, fun time now, everybody. So top emerging concerns. Well, this is not an official list. Okay, this is just me with I don't know, whatever Adobe stock images and a brainstorming session with myself on 10 problems out of a list that could be hundreds long. And these are in no particular order of nasty to least nasty. Each one of these is a nightmare and a 2-hour tech talk on its own. But I'm throwing them out here for the sake of time. If anybody's researching on any of these issues or they want to talk about them some more, drop them into the questions so we can unpack it. I don't want to talk about something if nobody's interested in it, but I'm happy to gab on if any of these things are particularly a problem. I kind of focused my presentation on the first 2 or 3 of these, but I'm happy to go into our experience with the other ones and anything else like that. And then I also put together this slide, which was from Veolia's website. I'm sure you guys know Veolia. They're a phenomenal company. They deal with the real problems. They deal with all the big issues that are out there. And they had a list of the top 10 water challenges. The top 10 water challenges as they saw it. I find their list fascinating to me for lots of reasons. But anyways, again, if there's anything on here that you wanted to unpack or talk about, aging infrastructure is a great one. The workforce development, or basically the real shortage of qualified operators, is a very, very interesting one. And we put a lot of work in our systems into automation, surprisingly AI and a bunch of other things as well, to be able to provide as, sci-fi or robot system as possible to our customers. So because there's just nobody around to do the work anymore. So that's a real challenge, but one we deal with all the time. Okay, so in the sake of time, I'm going to just go to my last slide here. So this brings me to kind of the end of what I wanted to talk about, and I did want to leave this on a happy note. So, fixing water. Am I optimistic? Yes. Am I bullish on the future? Absolutely. Do I really think we can pull together the next generation of leaders around the Great Lakes who can successfully demonstrate the world of both how we can demonstrate to the world both how we can grow the economy in a sustainable way, but also how we can do it to all get along without killing each other too? Yes, I think it's happening right now. I really believe that we have what the world needs in this region. And, it's a great time to be alive as far as I'm concerned. I mean, it doesn't mean that it's not problems from day to night, but, as long as you don't go on the internet and you don't doom scroll your way to oblivion, that's another conversation. But, I really think that there is a phenomenal sort of uprising of like-minded people coming together that are trying to help Ontario and the Great Lakes region grow sustainably. And that's where I wanted this talk today to sort of go to maybe be the jumping off point to kickstart some additional side conversations, hopefully collaborations to help move this conversation forward. Econse is a company that thinks about things and builds things. And more often than not builds things that work. And I think that there is a real phenomenal opportunity to sort of collaborate between the field work guys and the research departments to actually be able to help articulate some of these issues, so that the people that are in the places of the decision makers, whether they be in government or business or just the community in general, help them understand something, because there's an information overload out there. And this is something that needs to be understood simply, intuitively, and passionately, because it does kind of affect everything from your mental health to your family's health to what your hopes are for the future. So we got to get it right so we don't end up with the wrong kind of green future. So that's my presentation, and cheers, everybody. Thank you.
Great. Thanks a lot, Derek. There's time for questions. I see that there are already 2 questions in the Q&A box. So I propose that we start with those. Caroline Hill-Smith is asking that she's stating that she consults with municipal officials in the stormwater and runoff space, particularly with respect to road salt, which is so difficult to attenuate. Do you have any insights into stormwater ponds infrastructure design that effectively stop road salt runoff? I suppose that it is number 8 of your list, rising salinity.
Yeah, that was a big one. There's some work that was being done at Ryerson that I was really blown away by. And it was a simple idea of brine. And I don't know how deep they went into their study, but the headline was brine is better than rock salt for impacting, for how it percolates or gets into the environment. And I couldn't tell you why. I'm just guessing it's probably less concentrated, but still gets the job done. That made me start to think about how many opportunities we have to recover brine from industries, swimming pools, and on and on and on and on and on, that could help reduce, the rock salt being applied in the first place, because we use it pretty liberally here in Ontario. I mean, you know, everybody knows the bottom of their pants and shoes are white come January, not just from snow. When it comes to the ponds themselves, this is really what I'm talking about. You know, like the more upstream we can make an impact, the better it is downstream, because there's not a lot short of membrane technology that pulls out salinity once it gets there, and that's not really what you want to be using. Um, it's a very interesting one, and one that I think needs further study. I could come up with a bunch of crazy ideas on what may be worth trying, from biological that focuses on it to absorb it or consume it, to you know, other types of technology that can try and extract it for another purpose. But those are all like bench scale at best, right? So on scale, which is a big problem, the low hanging fruit is how can we use less rock salt and not slide off the road? So that's kind of my thought on that one. I hope that helps.
Thanks, Derek. Dana Simon is mentioning that she believes that you had water diversion in your list and asks if you could elaborate a little bit more on that one.
Well, yeah. So um, far be it from me to be the expert on, because of the complexity of this, but I've noticed on my scrolling through YouTube videos around the world and this, that, and the other thing, I'm seeing more and more talk about diverting water from one region to the other. So is that terrible? Seems weird to me, but I mean, then at the same time, if you have a community that's suffering, I mean, it's a real big challenge, right? Where is the water going? Why is it not getting to the right places? You're talking about it right now in California. I don't know. I don't know, but it's an emerging challenge. So when you have you know, water comes in two sizes: too much or not enough. We very rarely get it in the right amount. And when it's not enough, like some of our partners that we're working with down in Mexico and Central America, they have a real water shortage down there. And so they're rightly so. They're looking at what are the opportunities to do reuse? What are the opportunities for non-potable reuse, even just for the low-hanging fruit, to be able to be much more efficient with the water use? Those types of ideas make a lot of sense to me. More effective stormwater or rain capture, I think, are phenomenally good ideas where possible. I couldn't really say. I mean, it always kind of makes me nervous when I hear about, yeah, we're just going to change this river from here to over there. But I understand that this is a big problem that's going on. Like I said, we're really fortunate around the Great Lakes that we're like, what are you talking about? And yet it's probably already happening to divert some of the lakes. And yeah, like I said, it's so big, I wouldn't really be able to responsibly give an answer for that, other than it just strikes me as a weird choice that we do as a society.
Yeah, I actually think there is a regulation around the Great Lakes that it is not possible to divert it from one sub-basin to the other. It seems to be regulated here in the region. We have Angela Sun, who is asking a similar question, but in this case related to the treatment of tailing ponds. Can you elaborate a little bit more on the work that you do there?
Well, we were really lucky to be part of a project. This happened before COVID. So can we call that BC now? Before COVID, maybe? Okay. So we were working out in Sydney, and that was one of the projects that was brought together by Innovation Solutions Canada. And it was looking for alternative ideas for remediation of tailing ponds. And in my little deep dive onto that one, I found out a horribly awakening statistic that Canada is home to some many thousands, tens of thousands of abandoned tailing ponds. Forget about new ones. Abandoned tailing ponds, which, you know, are dammed up and waiting for natural attenuation, and you know, are subject to all the wild and crazy 100-year storm and climate change threats that are going on. And so a lot of these are in or adjacent to small towns or indigenous communities. So they feel to me like a ticking time bomb. And then you unpack the impacts from acid rock drainage, and you start to get a little nervous about water supplies, mercury poisoning, fish, metals in fish, and all the other heavy metal issues. So we were involved specifically around trying to come up with ideas for the remediation of tailing ponds. And it is a great idea. Currently, it's on our to-do list within the next, you know, several years, because I think we have to be, quite frankly, a larger company to be able to have the impact and be taken seriously with our ideas. This is one of the things, you know, this is a David and Goliath type reality for the water treatment industry, is that some of these are big problems, and we are rightly so very, you know, risk averse as a community to trying new things. But we had an opportunity to try something new there, and that was a super cool project, but it did have to go on pause because, you know, the world turned upside down for a minute. When it comes to the tailing ponds in Alberta, now we're talking. Now we're talking about big problems. And as far as my research into it goes, we're still looking into it. Like, not me, I mean, the industry's still looking into it. Nobody really seems to have cracked the code on how to affordably and practically convince the oil and gas industry that there's a solution. Probably it's going to end up in two buckets. Because I mean, there's a lot of political talk about drill baby drill and all this other stuff that's going on, and you know, that's beyond my scope to even get into. But probably there's going to have to be improved levels of efficiency so that the work that's done is more clean. And secondly, somebody needs to figure out the legacy problem, because it's a big one. And I haven't really seen any technology that seems like it can fix it like that. It's kind of a sad one to ask me about.
Thanks, Derek. It makes me wonder a little bit also, more generally about what your talk was about, is that you started off by saying that it's very expensive. A lot of these technologies, these cleanup technologies, are very expensive, and I think tailing ponds is a good example of there are potentially solutions, but they are very expensive, is my understanding. What I was wondering about a little bit is, knowing that these solutions are so expensive, what are, generally speaking, the drivers and the incentives for cleanup, and are they not lacking, perhaps? Because what is the incentive of cleaning up the tailing ponds if they can just stay where they are and no one is forcing anyone to clean them up? And we actually met I think in July, we met at the Council of the Great Lakes Region Sustainable Development Forum, and I was moderating a group of people from industry there, and we were talking about water conservation, for example. And the issue there was very much that there is no incentive because the water is so cheap. They don't see any need for water conservation. And so in the case of cleanup, what do you think needs perhaps to be done to incentivize and to actually scale up some of these technologies that I personally think are already there? I don't understand why they are mentioned as an issue in the Viola list as number 2, because I think a lot of those technologies are actually already there. And then financing is usually one key component, also with aging infrastructure, which is number 9 on that list. Anyway, if you have any thoughts of that, could you share this with us?
You nailed it, Roy. So incentives, this is where we live, because we're in a strange spot where, like, I like to consider Econse as disruptive technology. I mean, we're fundamentally a startup company, or we started as a startup company. I like to think of us as a small business now, that has punching above our weight by having exponential impact on the businesses that we work with. Every single business that I work with can double their production without doubling their impact on the environment. And I think that's phenomenal. And now we're starting to work on the municipal side of things after 10 years. We sort of left these domestic and sewage and waste to other people to do, but there really is a shortage of affordable options for a packaged wastewater system, a treatment plant in a box, for lack of a better word, which helps address these critical infrastructure issues surrounding the housing crisis. And so, again, can you double the size of your community without doubling your impact on the environment? This is the simple way that I look at this. And that's my incentive, is if I can do that, then there's a reason for my company to exist. So we work day and night to be able to do that and make sure that our customers are super happy. But no matter how awesome I make our system, no matter how much automation and efficiencies and, push button, set it and forget it, no matter how groovy and cool I make it, I can't compete with doing nothing. Doing nothing wins every time in terms of the business decision. So we can do nothing. Well, let's do that. You can't compete with no consequences. And so often I hear a lot of talk about water conservation, and I think that's the right, and incentives for water conservation. And I think that's the beginning of the right idea, but I think that the people working on that have got it backwards. I think the incentives have to be for on the end of it, because it's water in, water out. And I think that if they disincentivize pollution and they put a cost on pollution, oh baby, going to be a wake up. And it's not really hard. If you look at, okay, I'm gonna do a shout out to our friends in Halifax Water. They had implemented a rule that they utilize something called an extra strength surcharge agreement for their industrial customers, which allows them to pay the difference over the limit, using some calculation with an incentive to do better. Okay, so that used to be called pay to play, and I won't name any other big cities, but there's a lot of them where there's like, oh, absolutely, I'd be glad to give you $1 million to dump $10 million worth of garbage down the drain, which ultimately ends up subsidizing water pollution to the taxpayers. And that's part of that old school vision that we had as a society, that a business brings the jobs and we clean up the mess. And I think it's out of date. I think it is expected, cost of business now. It's expected of every industry that they need to consider their ESG. They need to consider their impacts, and most of them are there. And the ones that aren't, they're going to figure it out when public's, the sways against that, because nobody wants to be on the front page for being a jerk. Okay. But the unique thing that they did with Halifax was, in order to qualify for the extra strength surcharge, you needed to demonstrate that you had some level of on-site treatment to be able to mitigate or even try to reduce it. Otherwise, you're just going to let it rip. And even if that's simply like flow meters and pH dosing controls and sensors. Sorry, I'm glazing over this stuff really fast. But even if it's just some basic system for reducing, some of those things, it's a start. It's like, hey, let's make it incrementally better. And I think that was not really that difficult, because what they do is they implement it as a business is growing or expanding or opening a new location. And that's a really good philosophy to sort of get with the program, and then slowly deal with the legacy issues and grandfathered guys. Because nobody wants to be anti-business, and nobody wants to figure out a way that is hurting this. But again, I go back to my business card, my slogan: double your fun and double your pleasure, right? Double your business without doubling your impact. Well, doubling your business brings a lot of good things into the community. And when you can do that through technology, great. Um, because you're not doubling that loading and taking it away from another business being able to open up or add into that infrastructure system. So although reducing the water in or conserving the water within the facility is a cool thing, it doesn't address the issue of concentration at the end of the line. And so I know I'm talking specifically about businesses here. I think the incentives need to be around you know, a better management of the rules and regulations that are already in place. They're just, quite frankly, not enforced. And I think it would immediately solve uh, it would solve some of the rising costs for treatment plants that everybody's like, yo, why's my bill gone up? Well, sorry to tell you, but you're paying for all these all this loading at the treatment plant, the rising operational costs. It gives a shot to managing that. It immediately impacts combined sewer overflow because, yes, unfortunately, all the wastewater does not make it to the end of the line. It goes this way as well as that way, and that's a crime against humanity, but that's a conversation for another day. It doesn't need to wait for a $5 billion tunnel to solve combined sewer overflow if you're immediately reducing the loading going into it. Seems kind of common sense to me. And like I said, and the third thing is when you can reduce the effluent from a business, you've got more capacity for either more homes, more communities, more whatever. And now you're back in business. Small town XYZ can't grow. Well, now you can because you don't need that $50 million upgrade to the treatment plant to reduce orthophosphates going into your lake. And so, yeah, that's kind of my thought on that one. Did I come close, Roy? Did I get it?
Very close. That was very elaborate. Thanks so much. That was very good. And we need that business perspective as well that you bring in, because without business we're not really gonna be anywhere close, I guess, to
Totally.
sustainability.
Totally.
Yeah. So we have one more question in the Q&A box. It's an anonymous attendee, so I don't know who it is. But the person is asking, what technologies have you implemented and considered deploying to ensure your systems are as self-sustainable as possible to avoid issues of lack of skilled operators?
Oh man. All right. Well, I hope we have enough time for this one, but I'll try and talk fast. So it was going back to the days of COVID. It didn't take long for me as a small business owner to suddenly realize something was up. There was going to be a challenge. There was going to be a challenge for the economy. There was going to be a challenge for my customers, and there was going to be a challenge for my business, big time. And so this is a great little question here because I get to weave and take a small tangent here to do a shout out to the team at Waterloo's Institute of Nanotechnology. I asked one of my engineers, dude, like we got to do something to keep everybody busy. So they got little projects, but we can't make hand sanitizers and masks. We got to find something that can help our customers. And they came up with ultimately what's called OzoCav. And you guys can go to ozocav.com. And it's a surface disinfection, chemical-free surface disinfection system, which we helped develop with the nanotechnology team over there and validate it through our little COVID project. So that was what we did during COVID, number one. What we did during COVID, number two, was got a phone call from our clients who said, Derek, we only have a skeleton crew, and we don't have enough people to operate your system. Can you guys help us? And I was like, you got it, we're on it. And so between me and my partner Neil and some of the other guys in the team, you know, we got our work clothes on and our boots and rubber boots and wrenches, and we went out there and we started doing the kind of the daily tasks, the daily checklists on these systems. And they were already pretty automated, but they did require a certain amount of user interface each day. And I think about on week 2, I called up Neil, who does all the system designs, and I was like, dude, if you do not fix this design now, we're going out of business. Because if I'm climbing up ladders with buckets, you know, we're toast. Like we don't have the ability to keep going like this. And so we used it as an opportunity to sort of completely redesign our system, redesign our concept of how we do treatment, utilize less bottlenecks or places that could potentially have a pinch point or a challenge that would stop everything upstream, and create more of a concept that was continuous real-time treatment, and each module added a different level of treatment without impeding, you know, if it went offline. And we taught ourselves like crash course in automation, and we basically turned the whole system into a robot, fully automated system, and that allowed for from, you know, daily to weekly to monthly to quarterly service intervals instead of, you know, on the clock. And now we've got it where, you know, the current status of our systems across Canada is you know, about a 5-minute check-in a day, maybe a little half an hour once a week to do some housekeeping and maintenance on solid management, followed by a monthly or quarterly service interval from one of our technicians. And that's the sort of like cadence or rhythm. You guys, you're my clients, you guys act as just check in and let me know if there's weird squeaks, squeals, leaks, splurts, whatever. And you know, just do a little check-in. Meanwhile, we'll do the heavy lifting on a quarterly or a monthly basis, depending on the size of the system. You know, I got from like mom and pop little craft breweries all the way up to the largest farms in Canada. So, you know, so there's a variety of applications in there. Anyways, the long story short, that turned out amazing. The current thing that we're doing to take that innovation to the next step is working with AI. So we have a phenomenal partner, and we're building a ChatGTP Copilot that sits on top of our system as the customer interface. It will be multilingual to address the fact that we have customers with all kinds of diverse workforces, from the temporary foreign workers in the agricultural space to you know, across into the US, where we've got, you know, dual languages, and Canada as well. That is going to act as the interface for troubleshooting, training, alerts, alarms, reporting, monitoring, and it's sick. It's phenomenal. I can't believe how well it's working out. And so probably later part of this year or early next year, we'll have a little video update on how that's going. Again, this is something that was probably designed for mega utilities and big corporations, but we found the use case was in small to mid-sized businesses where they're growing, but they don't have enough skilled labor to do this. And if they could hire someone, they want to add someone else for the production line or somebody else in marketing, not somebody else to stand around in the back and smell like crap and, you know, hang out with buckets and ladders and stuff like that. So there you go. That's what we're doing.
Thanks a lot, Derek. We need to stop here. It's 1 o'clock, I'm afraid. So thanks very, very much for your wonderful talk. Thanks also for taking the time to talk with us afterwards and answer all the questions. The audience, thank you so much for participating today. I look forward to see you again in a month's time on the 13th of November when we have our next webinar. We'll have someone from Ontario Power Generation give a talk about the interaction between water and hydropower values. It's Kurt Cornelson. He's the Director of Environment and Climate Change at Ontario Power Generation. Thank you all for joining. Derek, once again, thanks so much for being with us. I look forward to follow up with you and hope to see you all again in a month's time. Thank you very much to Julie for the production in the background.
And thanks to everybody. I just put my email in the chat there. So if anybody wants to reach out to us afterwards about any questions, collaborations, you name it, I'm easy to find. Or you can go to econse.com. Thanks so much for having me, guys. I really love this today.
Thank you. Bye, everyone.